year 1990 with an intake of 30 undergraduate students. Since its inception, the department had made several strategic changes in the curriculum of the to prepare students for tomorrow's workplace challenges. Currently, the department has 90 undergraduate students total capacity, and department have also started MTech and PhD programs from year 2006. So let me just brief all the participants and respective guests about Chembion. So Chembion was started in year 2020, and it was organized by Dr. B.R. Ambedkar and National Institute of Technology Jalandhar under TechUp 3. The first edition of this conference was dedicated to the 550th birth year of celebration of Sri Guru Nanak Dev Ji. In our first edition of Chembion, more than 200 papers were presented by academicians and researchers from eminent institutes of various countries such as United Kingdom, Canada, Japan, Saudi Arabia, Abu Dhabi, South Africa, Nepal, and of course, India. In our first edition, the Journal of Chemical Indian Society, SCI and Scopus Index Journal of the prestigious Indian Chemical Society was the publishing partner. Out of 200 papers presented, 35 quality papers were selected for the special issue, which was published in year 2020. Then in year 2021, pandemic hit us all. Because of the pandemic, the second edition of Chembion was organized in virtual mode. It was a self-sponsored event and exceeding our expectations, more than 400 papers were received from the participants all over the globe. In our second edition, the publishing partners were Environmental Technology and Innovation, Elsewhere Publication, Environmental Science and Pollution Research, and Nanotechnology for Environmental Engineering, Springer Publications. Along with these, Springer Proceeding Book Series, Environmental Science and Engineering was also published. And today, we all gather here for the third edition of Chembion. For this third edition of Chembion, by keeping in view of future collaboration, it was decided by the organizing committee that this time the conference will be organized jointly by Dr. B.R. Ambedkar, National Institute of Technology, Jalandhar, and B.V. Raju Institute of Technology. I would like to thank all the members from BVRIT for jointly organizing the third edition of this conference and hope this collaborative event takes Chembion to its new height. I also like to thank authorities from NIT Jalandhar for giving permission and necessary supports for organizing the third edition of Chembion 22 in collaboration with BVRIT. With these words, I would like to congratulate the organizers and wish a grand success to the conference and hope this collaboration with BVRIT will further grow in future. Thank you.
Thank you, sir, for sharing the history and importance of Chembion. Now, without any delay, let us welcome our favorite head of the department and the convener of today's event, Dr. G.B. Radhika Garu, onto the dais. Now, I would like to invite Dr. K. Lakshmi Prasad Garu, Principal, BVRIT Narsapur, onto the dais. Now, it's time to call upon today's guest of honor, Shri V. Kiran Kumar, Chief Manager, CPET Hyderabad, onto the dais. Manager of CPET who pursued his MTech in Usmania University under the specialization of Material Science and Technology. With over 30 years of experience and 30 publications, Sir has wide exposure in plastic materials, blends, alloys, and nanocomposites, along with plastic testing and quality control.
Now I honor to invite today's guest, Dr. S. Reber, Chief Scientist, IICT Hyderabad, onto the dais. Dr. S. Reber is chemical engineer from University College of Technology, Usmania University, Hyderabad, who has been working as scientist in the area of membrane separation process at CSIR IICT Hyderabad for past 20 years. He completed his PhD at Karnataka University, Dharwad in 2007. He has done several projects and has also written nearly 40 books with many publications with 4 patents. He has been awarded several awards, among which the prominent ones that are named today: Talented Industrial Biotechnologist Award in 2018, Gandhian Young Technological Innovation Award in 2017. Welcome, sir.
I request all the dignitaries on the dais to start the customary act of lighting the lamp, and I also call upon Ms. Rihita.
And Ms. Rohita for the prayer, sir.
शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपज्योतिर्परब्रह्म दीपज्योतिर्जनार्दनः दीपो हरतु मे पापम् दीपज्योतिर्नमोऽस्तु ते दीपो हरतु मे पापम् दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते.
I'll take this. Thank our chairman, Sir Sri K.V. Vishnu Raju Garu, for joining us today. Thank you, sir.
Now, let us have the pleasure of hearing to the opening remarks by Dr. G.B. Radhika Garu.
Respected dignitaries, Chief Guest of today's function, Dr. S. Sridhar Garu, Chief Scientist, Indian Institute of Chemical Technology, Hyderabad. Our guest of honor, Sri Kiran Kumar Garu, Chief Manager, Central Institute of Petroleum Engineering Technology, Hyderabad. Sri K.V. Vishnuraju Garu, our beloved Chairman, sir. Sri Ravichandran Rajgopal, sir, our Vice Chairman, sir. Sri Aditya Visam Garu, our Secretary. Dr. Lakshmi Prasad Garu, Principal, BVRIT. Professor Srikanta Dinga, sir, from BITS, Hyderabad. And the team from Invensys and today's keynote speaker, Mr. Ravi Shankar and his team. Dr. Ramesh from Sir, Principal Viper. Mr. Satish Chandra sir from Placements, SVS, Vedic team, heads of the departments, deans, faculty from other institutions, CBIT, Anurag, and dear colleagues and my dear students and all the participants. A very good morning to one and all. On behalf of the Chemical Engineering Department, BVRIT Institute of Technology, I take the privilege to welcome you all for the inaugural session of the third International Conference ChemBiome 2022. The Department of Chemical Engineering, BVRIT, is associated with the institution right from its inception in 1997. We have strong and well-qualified faculty from reputed institutions, and we are offering UG, PG programs and PhD programs, and the institute is UGC autonomous and NAAC accredited. The department is accredited by Tier 2 MBA thrice and is reaccredited by Tier 1 in 2022. We have good number of core placements every year, and our alumni are part of various reputed organizations of global repute. So chemical engineering as a field ever evolving its scientific innovations and technological advancements. This conference ChemBiome provides an opportunity for the participants to brainstorm new ideas and identify new areas of research. It also provides premier interdisciplinary forum for scientists, industrialists, academicians, researchers, and all scholars. This conference will also open avenues for participants to identify new areas of research. And coming to the conference, this conference is spread over 2 days in a hybrid mode. And I'm happy to share that we have received papers from India and abroad. And out of which we have accepted around 200 papers. And the sessions, 7 parallel sessions are planned every day. And the keynote addresses on advanced technologies from eminent personalities spread over 2 days from various reputed organizations across the globe. And this will add flavor to this conference. And we are extremely happy to collaborate with Department of Chemical Engineering, NIT Jalandhar, to host this conference. I'm highly thankful to the opening remarks by Ratan sir and the head of the Chemical Engineering Department, NIT Jalandhar. And I congratulate Dr. T. Srinivas and Dr. G. Srinivas on this platform, Faculty of Chemical Engineering, Department BVRIT, who made this collaboration possible. And also happy to share that they have received the grant from DST to organize this conference. We are grateful to the Department of We are highly grateful to the Department of Science and Technology and sponsors from various industries for supporting us in this event. And I take this opportunity to convey my heartiest greetings and best wishes to all the participants, and hope the takeaways from the conference provide an opportunity for them to brainstorm new ideas and giving scope for further technological advancements. Thank you, one and all. Have a great day.
Thank you, ma'am. We are profoundly elated to invite Dr. K. Lakshmi Prasad Garu, Principal BVRIT, to speak a few words.
Good morning, everybody. Honorable Chairman Sri K. Vishnuraj Garu, who joined online. Our respected Vice Chairman were also, who is joining online. Beloved Secretary Sri Aditya Visam Garu, and the chief guest of today's inaugural session, Dr. S. Sridhar Garu, Chief Scientist, IICT Hyderabad, and the guest of honor for today's inaugural session, Dr. Kiran Kumar Garu, the Chief Manager, CPET Hyderabad, And the keynote speaker, first keynote speaker of today's deliberations, Sri Ravishankar Garu from Invensys, along with his team, Professor Srikanth Garu from BITS, Hyderabad, Professor Ramesh Garu, my colleague, Principal Viper, and our Director, Vedic, Dr. Shivkumar Garu, our Industry Relations Director, Sri Satish Chandra Garu, teams from Reddy's Labs and other industries, the participants who joined online from various parts of this country, the co-hosts along with us, the team from United Jalandhar, who is really instrumental in collaborating with BVRIT and making it into a shape of what we have today, and other invited guests and my dear students. A warm welcome to you all for this inaugural session of Chembayan 2022, combining the chemical engineering, biochemical engineering, and environmental engineering. Put together, this international conference on 3 themes is being organized in collaboration with the NIT Jalandhar. Just to the brief of the participants who joined online from various places across the country, I wish to bring to your notice that the BVRIT was established in the year 1997 and chemical engineering branch was there since inception, and it's just in the silver jubilee year now. Recently, we have organized our silver jubilee celebrations as a part of the silver jubilee year, and immediately after these celebrations, this is the first event that we are organizing on the academic side to organize an international conference. The main focus of this conference is to bring the industry people and the academia together, and of course the researchers from the academia also join and see how best we can really collaborate with the industries so as to solve the real-time field problems. That is the main focus of this conference. So that's how we invited many industry people to this conference. And now BVRIT Institute of Technology, in short BVRIT, is offering 13 undergraduate programs, almost starting from civil engineering, mechanical engineering, electrical, electronics, conventional core branches. Apart from this, the chemical engineering, biomedical engineering, pharmaceutical engineering, all these 3 core branches are also being offered here. And the cutting edge technologies, CSC, IT, AML, data science, and data science, computer science, and business systems are the cutting edge technologies. So the institution is catering to the needs of both the core industries and the cutting edge technology industries. And then we have over 5,000 plus students on campus. And then over 350 faculty members catering to the needs of these students. And the campus is so vast that it is a 110-acre campus, wherein we have facilities for the students' residential facilities and faculty residential facilities we have on campus. In short, the campus is perfectly a green campus, wherein we really follow all the what you call it as the audits of green audit, and we really basically keep this campus as the what you call it as a vibrant campus with various activities on campus apart from the academics in the form of co-curricular activities and extracurricular activities. The campus itself is unique in the sense that it's a self-sufficient campus that which caters to the needs of all the faculty and the students of this institution. And coming to the today's conference, mainly the today's conference focuses on three themes, as I mentioned, to bring the industry and academia together on a single platform wherein the exchange of ideas will finally trigger into some new research process or areas wherein the what you call it as the exchange takes place vibrantly among both the researchers, the scientists, and the academia and the industry people. I am sure that the 200 papers which are received from over almost 10 states in this country, and apart from the speakers from outside the country, and we have chief speakers also from abroad speaking on this occasion over these 2 days. So all this together will really expose the participants to various themes were really taken out across the country and across some of the countries. So that will really enrich them in really understanding the main important theme of this Kimberlin 2022. And I am sure that the organizers have made elaborate arrangements in taking out the deliberations to everybody in different ways. So I thank all the entire organizing team, both from BVRIT Narsapur and NIT Jalandhar, for making elaborate arrangements for simultaneous discussions at 7 places so that the discussions reach to the participants, every participant. And at the end, actually, I'm sure that the deliberations will really bring out some concrete proposals which can be taken out as what you call it as the takeaways from this place and take it their research into next level for every participant. With this, once again, I thank all the guests who have come here with our request and the guests who joined online into this program. And I really wish this conference a grand success. Thank you very much.
Thank you, sir. Now, I request today's guest of honor, Sri Kiran Kumar Garu, to share his view on today's events.
Morning, everyone. Respected Chairman Lakshman Raj Garu, then Vice Chairman, Principal HOD Chemical, and my friend Sridhar Garu, who is the chief guest, dear colleagues. Firstly, I congratulate BVRIT management for completing 25 years in this campus. And 25 years looks very simple, but it has a lot of hard work and so much hard work behind the screen to reach to this level. And I really appreciate Radhika madam for taking a lot of efforts. I could see, I think I have seen her from the beginning of this college. I think she may be the foundation for the chemical engineering over here. And normally being a chemical engineer, I get ignited by seeing chemical engineers. Not that we don't get ignited with other engineers, but definitely chemistry starts with a chemical engineer. So which type of chemistry that and all, I think our professors will take college lectures in the college. On this occasion, I want to tell to all the students and faculty, mostly parents guide us for the engineering. Okay, because parents definitely they think good for ourselves, for our good future. Maybe they have brought us into this, and definitely parents are thinking means there is God's advice to them to go to this level. And definitely every parent will think best for their child. And we have come to this organization, we have joined this engineering, means we should excel in it. Have passion in your course so that you can excel well. Don't think that I didn't get IT or I didn't get in bits or I didn't get in blah blah. It will be there everywhere in life. If you are getting satisfied at one point, then that is the end of your life. You will become Buddha. So there should be an ignition in our body so that we should grow and grow and grow. Then only we can go ahead, and that only makes our life easier and important and a meaningful life. So this is one piece of advice I want to give to all the students, and have a passion. Have a passion on your subject. If not any subject, there may be so many branches, so many electives will be there in our course. Have a passion on one area, and so that you will be developing in that area, and definitely you will get rich ideas. When you have a passion, you will be getting good ideas. So that way I joined the petrochemical stream. Then we have a passion. So have a passion in it. And lot many people ask me, you are 30 years in this organization, no change. Sometimes they ask, but because it is my passion in that chemicals, petrochemicals, we have been working in that. And you all know plastics is one of the petrochemical, topmost petrochemical, and without which we don't have a daily life. You just see a daily life, at least 50 to 100 products which you use in your daily life are plastics. And I used to tell in so many places, plastic is like a salt in your food. Whatever you see, unless until plastic is not there, it won't be a complete one. So like salt in food, unless until it is not added to food, taste will not be there. The same way, the petrochemical sector also is there. And but again, more salt also is not good for health. Again, we have to control our BP and everything. Those things are there. So sugar and salt, we have to balance. The same way, we should have a passion, but we have to balance our life also. So have passion, love your course, love your job, and love the place where you work and where you live. Then only you can make a positive energy in that area, and you can be positive, and positive vibes will come there, and definitely you'll have a very good life. So I don't want to take much time because professors are there, then so many technical sessions are there. That's why I'm teaching, I am just telling you just on the other side of the life because it is our experience. Definitely in your faculty, every day they may be telling you read this, this. I don't want to go into the subject now. Have passion, have faith in yourself and move forward. With this, I congratulate once again the management and the whole team of BVRIT and other faculties who have taken a lot of pains in coming and attending here, and a lot of people patiently on the online listening to us. So once again, I wish you and all the best. Thank you.
Thank you, sir, for encouraging and enlightening words.
Now we request our chairman, sir, a man of distinction and fountainhead of enlightening ideas, Sri K.V. Vishnu Rajagaru, to address the gathering.
Can you hear me? Is the audio clear, Revant?
Yes, sir.
Yeah. So I'm very happy to be here today morning for this Chem Beyond 2022. I'd like to congratulate Dr. Radhika. Also, I'd like to thank NIT Jalandhar for having supporting this very good initiative, and also DST. I'm a chemical engineer myself, and unfortunately, I could not be physically present because of a family function I had to attend. I would also like to congratulate Dr. Radhika and team for completing 25 years in the field of chemical engineering in BVRIT. And many participants are probably not aware, the founder chairman, my grandfather, late Padma Bhushan B.V. Raju, who was a doyen of the cement industry, himself was a chemical engineer. And because of him, I did chemical engineering. And that's how, in those days when this college started, chemical engineering was also part of this college. And my only submission to the panel and to all the participants, because we have a lot of good chemical engineering faculty, professionals from the industry, students, all attending this program. There is an alarming trend of lower enrollments in chemical engineering all across the country. So I think as Dr. Kiran Kumar Garu of CPET said, and I'm sure Dr. Sridhar also, our chief guest, will also agree to this. Without chemical engineering, a human being cannot get up in the morning and sleep in the night. There's chemical engineering in every minute, every 1 hour, every part of life. But the general public is not aware of this. So how do we make chemical engineering more attractive for the students? And it's become a very interdisciplinary subject. And I'm sure Mr. Ravi Shankar, who's going to talk first keynote address, because Invensys is also is mainly into automation control systems. So a lot of interdisciplinary, I think, subjects need to be incorporated in chemical engineering. Obviously, artificial intelligence, machine learning, robotics, instrumentation. And my request to the team here is that how do we propagate the future of chemical engineering? How do we make it attractive for students? And I would like to thank NIT Jalandhar because they have 90 UG seats in chemical engineering. It's fantastic. I myself studied in NIT Trichy. Those days when I studied in 1981, we had only 30 seats, but I just checked up, they have only 40 seats now. That way, I'm happy that Jalandhar has gone to 90 seats, and I think they are playing a big role in promoting chemical engineering in the country. And also, I would like to tell you, Hyderabad is probably the second largest hub for pharma industry after the Western Zone, that is Mumbai, Gujarat. So we've also introduced pharmaceutical engineering about 6 years back, and there was a lot of opposition from the technical education department in Telangana. They didn't want us to start pharmaceutical engineering. And the reason we started pharmaceutical engineering in the UG level is because pharma industry around Hyderabad asked us that we require pharmacy students who can scale up processes for us, who can actually make our products more commercially viable. We also want chemical engineers who understand pharmacy. And that's how we started it. And we struggled for the first 3 years because even to promote the branch, a lot of people were not aware what this branch was. But I'm happy to tell you, last year, all our seats got filled up. There's a good demand for this branch. So I think if this team, I'm sure you have a lot of good scientific papers being published, being presented in the next 2 days. My request, because we have eminent people, scientists like Dr. Sridhar there, people from CIPET like Dr. Kiran there, people like Ravi Shankar from Invensys, a lot of people from the industry, academia, NIT Jalandhar, and a lot of people. Can we also think about how to promote chemical engineering and make it more attractive for students? And my own experience, when I joined, I took it as my own choice. I liked chemical engineering. I saw what my grandfather was doing and I took it. And even now, I apply some of those concepts in my day-to-day work. So that is one request I have from the team here. And how do we make it more attractive for students? How do we promote chemical engineering? And with this brief background, once again, I thank the organizing committee. I think from both NIT Jalandhar, that is Dr. Anjireddy Garu, Dr. Deepak Sahu, Dr. Nitin Pandare, our own team from BVRIT Narsapur, Dr. T. Srinivas, Dr. G. Srinivas, Dr. Appal Naidu. Thank you for organizing this conference, Chem Bio Engineering. Also, I'd like to thank the conference chairs, Radhika ma'am, Dr. Renu Gupta, HOD, NIT Jalandhar Chemical Engineering Department, and Dr. Jatin Kumar Ratan. Thank you all, and I hope all of you have a good takeaways, and these 2 days are very productive for the field of chemical engineering. Thank you very much.
Thank you, sir.
Now, I request Dr. S. Sridhar Garu to enlighten us with his words.
Respected Vishnu Raju Garu, a great pioneer in the field of education and chairman of the Padma Shri BV Raju Institute of Technology, vice chairman, team from NIT Jalandhar. I could see Professor M.K. Jha, a stalwart of IICHE, and other members who have joined online. Principal Lakshmi Prasad Garu from BVRIT. Today's one of the most important persons, GB Radhika madam, who has conceptualized this program. Chem Bio, my good friend Kiran Kumar Garu from CPET, one of the most brilliant engineers I have seen in this CPET family. Came from Invensys. We have heard many people getting absorbed in Invensys and working well there and development of software, etc. Keynote speakers of today, Professor Dinda from BITS, Hyderabad, staff and organizers of BVRIT, and the future of our country, which is our students, the future professionals, engineers, entrepreneurs, and the teachers and industries, which is all of you students. So the future belongs to you, and this seminatory conference is basically to help you not only to present your knowledge, but also to interact with others and look for interdisciplinary opportunities where you can find application. So I remember in 2001, the first batch of BVRIT students came for their final year project at IICT and they worked on effluent treatment, and it has been an excellent association with BVRIT ever since then. And I remember some of them had gone abroad. The four out of those four students, I think three went abroad. So if we see the most highly paid profession among engineering in the US is chemical engineering. It is a passport to the USA, we can say. And also the second highest paid profession in Germany. And in India also, there are several opportunities. Research can be a career. I never thought about it when I myself finished my BTech. I was looking out for a job. But research came forward as a career where you can get a handsome stipend and also you can get your higher education, MTech. After BTech, you do MTech. And then after MTech, you can do your PhD. And then after PhD, you can get a very handsome salary as a postdoctorate. Or otherwise, you can also come back and teach. Like I am very, very happy to see BVRIT encouraging its former students with jobs here. And I believe they are doing a wonderful job. I can see some of them, Raghavendra and Bhaskar and many others who have joined here after doing their PhD. So it's a wonderful platform to teach and impart knowledge to the students, whatever they have learned earlier. So that is also another aspect of the career. So research and then teaching, and then of course industry has got a lot of opportunities for chemical engineers, and whether it is aerospace or automotive, or whether it is biomedical and medical, drugs and pharmaceuticals, as Vishnu Raju Garu said, Hyderabad is the second hub after the Western Zone. So there are many opportunities in different fields. Effluent ETP and STPs, effluent treatment, municipal wastewater treatment, solid waste management. So now we see a lot of solid waste coming in. We hear about the dump yards and those things. So waste to wealth. So conversion of this solid waste into biogas and biomanure. So these are some of the areas where you can work on. Chemical engineering also finds application in AI/ML. So when ISRO sends a rocket to the outer space, 70% of the work that is involved is simulation and modeling. So there are a lot of opportunities for simulation and modeling as well. So in this way, there are plenty of opportunities for chemical engineers, but you need to diversify into different applications. And as Kiran Kumar pointed out, that passion is one word, and to get passion, you need to be in the area of your choice, which means that if someone is interested in reaction engineering, you must take it up on a really serious scale. I was interested in membrane, so I took up that one after my final year project in membrane under Professor Sitaramaya. So that got me motivated, and I really don't know how the day passes because I'm so busy. So morning to evening, it's very busy. Otherwise, if you are not having passion, then it becomes very difficult to spend the day. The work becomes a burden. So choose the field, the sub area of your choice where you have got the keen or maximum interest, and then pursue your PhD in that. Go for higher education, or you can always join a job in some of these industries, including chemical process industries or petroleum refineries or those kind of jobs also you can take up. We can find different applications. So last few years has been dominated by COVID, but scientists have defeated COVID, and one of the major contributors have been chemical engineers. From our side, we made a mask which was the first line of defense, and this mask called as safe mask. It sold about 6 lakhs to polypropylene spacer with cotton on either side, and it created job opportunities for 500 people, and it also generated a revenue of 2 crores for the NGO. So many people who lost jobs were able to send their children to school, the self-help women groups, the elderly. So it gave a lot of job opportunities. So in that way, a new concept or a new idea at the right time can help you to become an entrepreneur and contribute to the society. So with this, I would say that there are many applications that chemical engineers can find. One such example was when our chemical biology team approached us and told us that this millipore or molecule water system has failed, our cultures are getting spoiled, our microbial cultures are getting spoiled, our equipment is getting spoiled, please do something. So we came up with a double pass or cascaded membrane system. Followed molecules, whatever little less tedious was left over, and then UV treatment. And ever since that, they have not looked back. Since last 7 years, they have no problem. 2015 it started, and now a number of systems of medical grade water has come up, and more than 1 lakh patients have been treated in Nephroplus chain of hospitals and ESIC hospital in Sanat Nagar. And now we are going to install one plant in Milofar hospital, that's for children. So in this way, it has generated job opportunities as well as Make in India, Startup India. So we need not depend upon imported systems. So the belief in our own indigenous systems which are low cost is also important, both for the common man to believe in and also for the industry to believe that yes, our Indian technology is definitely better and cheaper. So this is very important for all of us to make the people aware of. So apart from that, there is effluent treatment which with zero liquid discharge. So plenty of opportunities for zero liquid discharge. So chemical engineers can work on these avenues. And then we also come to drinking water purification, food technology, and all the basic needs. Wherever the basic needs are required, you can do that. So when I came to the campus today after 6 years, this is my 5th visit, I was really delighted to see the wonderful development of the campus, and the entire credit goes to the chairman and his entire team here at BVRIT. And so big round of applause for them for this wonderful campus that has been created, probably the best in the Twin Cities or this Telangana region for chemical engineering and for other branches also to come and studying in. It's highly motivating. And what I would advise all of you to do is to take your mind off the pressure from studies. You have a very good sports complex, so go over there and spend some time there and develop a passion for either sports or arts or any other activity, singing, dancing, anything arts. So that you can again remove the stress that you have during your studies or exam fear or whatever. Just divert your mind and then come back and refresh. In a refreshed manner, you can come back and you can again work again very hard. So mind is very fresh and you can work very hard. So, ladies and gentlemen, this is now a very advancing era where technologies are developing very rapidly, and so you must plan your career well in advance, looking at the developments. Now, everybody is now talking about AI, ML, what we have seen in the last 6 months to 1 year. Everywhere it is now coming up. So look at these advancing fields and take up the field of your choice. And there is no substitute to hard work. There is no shortcut to success. So, but definitely one thing is for sure, that hard work pays, and it pays really handsomely, and you will develop a lot of passion. So I would like to wish you all the best to contribute your might to the Indian society. Go abroad, come back, and then again try to contribute something to the Indian society and the Indian industry. So when you contribute to the Indian industry, so indirectly you will be contributing to employment, HR, and also the economy of the country. So in this way, you can make your parents really proud. So they are your first God. So and then of course your teachers. So you must always give respect and regard for you to follow. And in this way, I would wish you all the best to make your family and your institution BVRIT really proud and our country proud. Thank you very much.
Thank you, sir, for your enthusiastic words and the awareness you given us. We are grateful. Now let us know what this conference was in store for us. I request Dr. Sridhar Garu, Guest of Honor, Dr. Kiran Kumar Gaurana, Principal K. Lakshmi Prasad Garu to release the conference souvenir.
Now we take the privilege to honor our esteemed dignitaries with this small token of memento.
I request Dr. V.B. Radhika Garu and Dr. Lakshmi Prasad Garu to felicitate Sridhar Garu.
And I request Dr. G.B. Radhika Garu and Principal K. Lakshmi Prasad Garu to felicitate today's guest of honor, Sri Kiran Kumar Garu.
Now, we would like to call upon coordinator of this international conference, Dr. G. Srinivas Garu, Assistant Headquarter, Department of Chemical Engineering, BVRIT Narsapur, to give the vote of thanks for this inaugural session.
Request State Minister to come to the dais.
Honorable Chairman K.V. Viswaraj Garu and Sridhar Garu, Guest of Honor Kiran Kumar Garu, and respected Vice Chairman Sri Ravichandran Rajagopal Garu, and Secretary Aditya Vishwan Garu, Principal Dr. K. Lakshmi Prasad Garu, and investors from delegates from investors, principals, and dear students and faculty. Very good morning to one and all. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get this opportunity on this special occasion. My special and sincere thanks to Dr. S. Sridhar sir and guest of honor Dr. Sri Kiran Kumar Garu for accepting our invitation and giving their presence in spite of their busy schedule. Thank you, sir. Thank you, Sridhar sir. Thank you, Kiran sir. I, on behalf of organizing committee, convey deep regards and hearty thanks to our Honorable Chairman Sri Vishnu Raj Garu for his appreciation, encouragement, and invaluable suggestions and support. I'm also thankful to the Vice Chairman Sri Ravichandran Rajagopal Garu and Aditya Vishwan Garu for their gracious support for this conference. I would like to thank our Principal Dr. Lakshmi Prasad Garu for constant help and encouragement at various stages of this conference. I would like to thank deans, HODs, and HODs of other departments for their suggestions and support in various stages. Thanks to our HOD our head of the department, Dr. G.B. Radhika Garu, for her continuous encouragement that radiate a source of energy within us. My sincere thanks to all honorable delegates from industries and delegates from the other institutions who blessed with their presence and participation. I'm also very much thankful to the program committee, advisory committee members and invited speakers. And also thanks to all session chairs and judges for accepting our request and giving their precious time. I'm also thankful to all colleagues and non-teaching staff who stayed with us and support in all the stages, all possible ways. And I express my sincere gratitude and thanks to Department of Chemical Engineering, NIT Jalandhar, especially J.K. Ratan sir, Dr. Nitin sir, Dr. Sahu, my friend Dr. Rangareddy sir, for giving opportunity to conduct this campaign in at BVRIT Narsapur. Last, we have been fortunate to enough backed by a team very motivated and dedicated students, committee and volunteers. If time is money, then today we have spent millions for us. Thank you all for making this event successful. Enjoy the conference. Thank you, Ananda.
That leads us for the high tea time. We'll gather here again in about 20 minutes for the guest lecture by Ravi Shankar Chaudhary Garu and his team from Aviva. Thank you all.
We cannot share the presentation. Yeah, the Wi-Fi can call it. Placement on the placement. Right. Yes, sir. Laptop, they won't share yourself. Can తిరుగుతా ఉంది. One second. Outlet, sir. Yes, sir, మీరు అయిపోయి సార్ పాయింట్ వస్తుంది. 1 second, for 1 second, please, sir. Give me 1 second, sir. Take a back at it. See. 4.1 box. 7.0. Excellent. The bandwidth issue. Yes, sir. Can you send me that link, Teams link? So is it possible? That WhatsApp. You can email me the link, right? Yeah, sure. Yes, sir. I got it. Type on. Type on number. feel that. Maybe just water. Take it away. About the connect.
Morning, everyone. We request the participants and the students outside to gather around because we are about to start the event. Thank you.
11. It's good morning. Thank you. I think we have few seats in the front row, right? Why can't the backbenchers occupy the front seats? Come on, guys. We still have some seats in the front. All right. So we are honored here to be part of this conference, and I know how difficult it is to organize such a conference at this large scale, right? Because at one point, even I tried to organize a conference along with my friends in my BTech days, and I know how tough it is. So congratulations to all of you who has successfully, organizing this event. I'm sure it is going to enlighten you guys, not only with my presentation or with our presentation, but with whatever other lectures and individual sessions that you guys have. Okay, so we three are from Aviva. It's AVEVA, to be very, very clear, right? Because we often are questioned, is it AVIBA? No, we are AVEVA. So we are going to take you through a lot of slides where we are going to talk about what we do at Aviva and specifically on modeling and simulation. Then further dwell into what is this OTS. Okay. So OTS is Operator Training Simulator. Just keep that in mind. So with that, I think let's start with our presentation. And before that, I would like to introduce ourselves first. Let's start with your alumni, Radhika.
Yeah. Very good morning to everyone. I'm Radhika. I have completed my graduation in chemical engineering from BVRIT in 2005. So initially, I have worked for 4 years in Reliance Industries Limited, Gujarat, and then Kakinada, Andhra Pradesh. Currently, I am working as senior consultant in Aviva for the past 8.5 years. Thank you.
Anil, our Principal Project Manager.
Good morning, everyone. My name is Anil. So I'm working as a Principal Project Manager at Aviva. It's been 12 years with Aviva now. Prior to that, I worked in Reliance Industries and Indorama, where mostly I was involved in the DCS panel operation. So on the past 12 years, here I'm working as a simulation engineer and currently as a project manager.
Thanks, Radhika and Anil. So my name is Ravi Shankar Chaudhary. You can call me just Ravi. Let's try to be very informal, okay? Don't think that we are from industry and don't call me sir and all. You can call me Ravi. I've done my MTech from IIT Bombay back in 2004. That's I passed it in 2004. So since then, I've been chemical engineer. You might have heard that. I mean, you might have heard Invensys, Aviva. Although they are software companies, I'll let you all know what we do exactly in such company. Okay. I have overall of 18 years experience. I worked for about a couple of years in BVRIT Petroleum Corporation Limited, their R&D center in Noida. Then I moved to Aviva, which was Invensys in when I joined this company in 2006. So I've been working at this organization for 16 years now. Okay, so I'm going to tell you the history of Aviva. You will understand why Invensys, why Schneider Electric and Aviva and all. Okay. So with that, this is how we have structured our presentation today. We will talk about who we are, what we do at Aviva, India team that we have here and also Hyderabad team. Then process simulation. We are going to talk about specifically on the operator training simulator. What are the emerging technologies specifically in this area and the role of chemical engineers. So before this, I was listening to your principal Lakshmi Prasad Garu and Vishnu Raju Garu, their objectives and expectations of this conference, right? So we believe that we are not going to disappoint you. I trust we have all these objectives captured in our presentation. In case you feel you want to understand more, you can feel free to stop us, interrupt us, and we can have an interactive section. Okay. Before I go into further, let me tell you a small story. It's a true story, and that happened to me. In 2003, 2004 time when I was studying my MTech, right? We had a professor who always used to say, you should have a feel of numbers. As a chemical engineer, you should have a feel of numbers. So I was like, how come numbers can be feel? I mean, how can we feel the numbers? Right. So then I got placed into BVRIT Petroleum Corporation Limited, and then maybe about after 3 months, I started operating a pilot plant. Okay. So I was in a night shift. It was a diesel hydrodesulfurization pilot plant, which involves hydrogen, okay, which is invisible fire actually. If it leaks, it's hazardous, and also it involves hydrogen sulfide. So I was relaxedly sitting in my chair and peacefully watching probably some videos or something, and all of a sudden I started hearing alarms. And alarms, when you hear alarms, right, when you're operating any plant, even a pilot plant, trust me, it is going to be crazy, right? I'm sure Radhika and Anil will agree because they worked in industry as well, so they know what is that alarm sound is. So all of a sudden, it was like 2 o'clock in the night, and I got panicked because I did not have training in that, right? To operate a pilot plant, all that I was told is, yeah, it is operating steadily. You need to monitor it, And once the run is done, just collect the sample. So I got panicked, and when I saw I think it was instrument air cylinder. It had a pipe. That pipe got broke. So you know what I did? Funnily, I went and started or tried to stop that gas leak, or it was air leak actually. I was stopping with my finger. It was pushing. The gas is like 10 bar gauge of pressure. Imagine. It was pushing my finger, right? And then I tried to stop it like this. Again, it was pushing. Then I started feeling those numbers my professor has told. He said, you should have a feel of numbers. So I felt the 10 bar gauge of pressure when this incident happened. Okay. With this story, keep this in mind. I'll connect to one of our slide when I come there. Okay. So who we are, what is Aviva and all. So we are a world leading engineering technology and service provider. I think we have about 2 million licenses across several customers over 130 countries. Okay, so we spark that industrial ingenuity by connecting people and digitalizing across the assets. We redefine that how to manage and how to accurately or how do you optimize your production basically. Okay. So this is our history of Aviva, wherein it's more than 5 decades of success that we had at Aviva. It all started in 1970. You see three lines over there, right? So 3 parts altogether. The reason for that is initially it was Simsai back in 1970, and it was acquired by Invensys. So that's how Invensys came into picture. Then it was acquired by Schneider Electric, which was part of Schneider Electric software. Parallelly, Aviva was also started in 1970, and they were having their own, team and organization and the business. So Schneider Electric had performed a reverse acquisition of Aviva, where we got merged with Schneider Electric. Then onwards, both the giants have been working together, and I think recently in 2017 or maybe 2019 timeframe, Aviva has acquired OSI PiSoft. Okay, this is again another world leader in the historian database of several industries. So we all together now is where we are here in Aviva. So with our unique solutions and products and the agile technology that we have, as you can see here, we have our presence in 49 of the top 50 chemical producers. All of the food and beverages companies, we have our footprint. Power industry, manufacturing, oil and gas, infrastructure. We work for Naya, what is that? It's a smart city, Naya Raipur. Yeah, so we have delivered our technology and innovation in order to come up with that smart city in Naya Raipur. Okay, so we also have our presence in water industry. And these are some of our popular products here. Aviva E3D, everything 3D, E stands for everything. We have Aviva PNVDs, diagrams, Aviva PDMS, that's Plant Data Management System. Aviva InTouch, it's a HMI. Aviva Pro 2, which is a process simulation. I guess some of you at least might have heard about it. Aviva Dynamic Simulation, which is popularly also known as DynSim. Aviva Process Optimization, which is popularly known as Romeo. Not the other Romeo, but this is rigorous online modeling equation-oriented software. And then we have Aviva Predictive Analytics. This is an interesting one. We have heard about AI and ML terms, right? So this particular product actually has the ML algorithms in it. We also have Aviva Connect, which is a cloud-based solution, and then OSAPI, which we already talked about. So with our massive install base across all the customers, these are some of our customers in each industry. These are several verticals, right? So each of the vertical or each of the industry, these are major giants. As you can see, energy, oil and gas, ExxonMobil, BP, Shell, Power, National Grid, Tata Power, food and beverages, Pepsi, Nestle. We have done a very interesting project with Nestle recently. I think it was delivered last year. That was a 3D OTS. Chemicals, giants like BASF, SABIC and all. Then infrastructure, we talked about this, Naya Raipur. Mining, marine, EPC companies. Okay. How is this all possible? This is possible by combination of technology and teamwork, right? There has to be teamwork and the appropriate technology, the innovation. So we have project centers and more importantly, R&D center. Specifically, if you see those dots here across the world, the combined R&D and project centers, those are one of our key centers wherein we collaborate directly with R&D and make, if we have to provide a feedback to them from the projects we deliver, they immediately implement what we require based on what customer needs. So we have about 6,500 employees. We also have system integrator partners. 16% of our revenue goes back into R&D. So about Aviva India footprint, we have about 1150 employees spread across Noida, Mumbai, Pune, Bangalore, Chennai, and Hyderabad. And if you see there, specifically in Hyderabad, we are about 60% of the headcount of overall India office. So we are one of the largest teams. We have one of the largest teams in Hyderabad office here. We talked about several industries that where we provide service. Again, these are customers where the Hyderabad office specifically is dealing with. And you can see ExxonMobil OTS, Shell OTS, ADNOC. This is a very interesting project that we have delivered. It's Unified Operation Center. You can probably Google it or check it in the YouTube. It has a huge panorama of screens where they can monitor the operations from there. And this is our simulation experience and capability spread across the world. As you can see, majority, the largest team again in simulation is in Hyderabad. Overall, we have 174 engineers across the world, specifically on process simulation. Okay, with that, let's move on to process simulation. Any questions so far? Okay, I'll take it as no, but does that mean that you all understood everything? Again, silence. No, this should be yes at least. Okay, let's go into process simulation now. And I would like Anil to continue from here for a few slides.
Yeah, so as you mentioned, we are into modeling and simulation, at least our department in Hyderabad here. So what is simulation is basically it is a digital representation of the plan. So we to teach or to train someone operator, they need to have a interaction with the plan, right? So they cannot do the things directly by going and sitting in the DCS. So that's where all the things go wrong, and many mishaps will happen, and that lead to accident. So this simulation are the digital representation of the plants. They will mimic all the plant activities, and so that will provide input to the simulator. And there are two types of simulators, that is steady state and dynamic. And these are the softwares which Aviva has for the catering to the modeling and simulation field. The first one is the Pro2, that is a steady state simulation. Hopefully, most of you must have at least heard about this software. This is a very good software for steady state simulation. This is used mostly in HMB. Most of the EPC companies use this Pro2. And the other one is, the next one is a dynamic simulation, ADS. We call it ADS. Now, earlier it used to be DynSim. So this one is the dynamic simulation software, which is used for training the operators. So we'll come to that when we go to that particular section of the DynSim. And the next one is the APS. This is very interesting software we have come up recently, like past few years. We have been working on it. Our R&D team is working on it. This has features like from design till planned implementation. Till that level, they can do various activities in that. And the next one is a Romeo. This is the one which most of the industrial people must be aware of, because this is the one which they will use for majority of the refineries, petrochemicals, and other industries. They will use this software to optimize their production so that their profitability will increase. So these are the softwares, and the other simulations also can be done with, if you have a coding knowledge, you can use either C, C++, and this Python. So these things can be used to code particular unit operations, like any operation like drum or valve or whatever it is. You can use that, if you have the coding knowledge, you can use those skills to develop some small unit operations, and you can simulate those with the help of that.
Yeah, essentially, these are ready-made softwares, right? The process simulation softwares you see here, these are from Aviva and they're ready-made, meaning the coding is done in the background. You just need to drag and drop the objects, drum, distillation column, heat exchanger, reactor, and so on. Whereas in MATLAB and C, I mean, these softwares also use C++ or Visual Studio in the background. But basically what we're trying to mention here is there are ready-made softwares, as well as if you have skills, then you can code yourself as well, right?
Just to add a few points, that these the coding part will come into picture whenever a client wants to have secrecy of their the technology or whatever. So they can code their reactions. Let's say if you have a reactor, and they don't want to reveal the nomenclature and the kinetics of the reactions. And what they can do is they can develop the reactor in that, and they can provide it to us. That will be like a black box. So basically, we'll provide the feed, or they'll provide the feed composition, and then that internally calculates all the product, and then it will just throw out the product. So we don't know what is happening inside, but we'll maintain the temperature or what are the required reaction parameters. So that way, you'll have all the final outlet product. So it's like a black box. So we can use it that way. And we can just hook it up to our simulations like either Pro2 or DynSim. So that will have as a products as a feed to the simulators. Yeah, and here if you see the simulation can be used for different fields, so like HMB. So HMB is called, you must be knowing HMB, heat and material balance. So this is the like primary thing when anyone wants to start a plant or industry. So what they decide is they'll go with their whatever the output they want to produce and what are the product they want to. So when they contact EPC or the licensors, so what they give is specific to that industry and that person or whoever is. So they'll provide a customized HMB solution. So that will have specific to that plant. So that has all the inputs like raw materials, and the rate of raw materials can be defined. And these can be developed in the Pro2, because that's what I mentioned when I said a steady state simulation. So this is where it will be useful.
I just want to add here. Yes, you must be going through heat and material balance subject, right? So probably it's straightforward, because you'll have a small drum or maybe a column in order to perform heat and material balance there. But imagine a plant. It's huge, right? So that can be easily established. The heating metal balance can be easily established using these softwares. So, I mean, hope you are trying to relate the importance of chemical engineers in this field. Okay.
So that's about HMB, and also the second one you can say training and decision making. So this is one of the important applications we have with our simulator. So this is where the dynamic simulators will come into picture. So majority of the accidents will happen due to lack of training because over the period of time the operators will come and go. Especially in the when at least I joined in the industry, there were like operators, they are not that skilled in front of the I mean in terms of the education qualification. So they used to feel very awkward, and they were reluctant to share their information. What they had was the insecurity of their job. So there was a situation, and then suddenly there were a few incidents started happening in our plant. So when the management started digging the reasons for that, then they realized that there is a shortfall of skill of the training, which is because the new people they are hiring, there were a lack of training. So, and then later on, there can be different ways of training, like classroom training and all. So, but the one you do hands-on that will have a lot of impact on your absorption of the skill. So that's where this will come into picture. As I mentioned, the simulation is just the digital representation of the plant, right? So they will, without going into the plant, they'll get to know what is happening in the plant. Like if there is a drum, what is the volume of that? If they want to drain it, how long it will take? So these things can be learned without even going to the plant and without seeing any incident. Okay, so that's about the training and decision making. I'll come to the decision making part later. Then the engineering studies. So these, again, it's something related to the EPC. And even the new plants are something which they want to expand. Let's say if they want to expand a plant, or there's a plant which they're newly implementing some control loops or something like that. So before implementing it in the plant, they can test here in the software itself, like providing all the hydraulics, that is the volume information of the headers and pipes, and then the elevation. Those details they can enter, and then they can see, let's say if you're looking at a compressor, okay, a compressor, you know that anti-surge valves are very key for operation, right? So those things, whether the sizing of the valve is sufficient or not, whether they are oversizing to, in case of oversize, that can go into the choke region. So those things can be tested and can be basically properly tuned, and we can find out the exact CV and the other inputs that can be given to the engineering team. So that will be useful even before implementing it in the plant itself.
Yeah. So these engineering studies actually are very interesting. They need in-depth knowledge of how to operate those equipment or the assets, as well as your chemical engineering skills there, because like he said, we will have to judge if the CV that is provided by the vendor, is it sufficient enough or not. At the same time, pressure relief valves, those are so important in industries, refineries and all. So you can perform these engineering studies and see whether the sizing is done appropriately or not. So that's, we have done a lot of engineering studies to several of our customers.
Yeah, and the other application we can see is optimization. So this is of interest for almost all the industry leaders and everyone in the industry, because this is where their profitability increases. Ultimately, then the market product prices are changing like every hour or every day. So they have to keep an update on that, and then based on that, they can change the product. So that way, even using the same raw material, they can get more productivity. So that's where this optimization tool will be useful. And the next one is the rating. So this is like, again, it's something to do with the EPC and startup of plant. So whenever there is equipment which they say that the vendor says that this should be able to work for certain conditions. Let's take a pump. Okay, so it can pump this liquid from this height to this pressure to this pressure, and it can handle so much of flow rate. So whether it will really able to handle that, or it can take more weight, more load or less load. So those things can be studied using this in the rating section of the software. And the last one is the design. So design and HMB, again, those go hand in hand. because once they done with the HMB, ultimately they have to go for the design part as well.
Yeah, so I mean, again, designing a plant is done by chemical engineers. Okay, so process simulation can be used in order to design the plant as well. Okay.
Yeah. So out of the 4 simulation products, what I've mentioned earlier, so this is the first one, which is like a steady state simulation. This simulator, it will take into consideration of all the first principles of chemical engineering, and it will try to get a solution. So the basic things are like conservation of mass and then conservation of energy. So these are the 2 things it will take care. And it won't consider the volume. Let's say there is a big plant and you are giving certain input, and ultimately to get the output, right, there is some reaction time or whatever, there is some lag. But here, if you in the steady state simulation, if you give the feed to it and proper specifications and then all the initialization values, then it ultimately reaches the final solution and gives you the product. So it's basically independent of time. It won't consider the time into time as one of the factors, and it will give you the solution.
To put it in another way, there is no accumulation, right? It's a steady state simulation. T tends to infinity, time tends to infinity, and no accumulation there. So this is one of our old products. Actually, it's being used in several industries, predominantly in refining and petrochemical complexes.
Yeah. So this Pro 2 has different unit operations like drums, valves, and then distillation columns, heat exchangers. So if you have the information and if you'd like to tune the things or get to know what is the kind of heat duty, or if you know the duty and you know one side of the process, right, we need to raise the temperature of this from certain temperature to certain temperature, and you know the other side heating medium, then you can say how much fluid is required to heat that. So those things can be easily get from this simulator. So that's one. Another thing is you can extract a lot of reports from it, and you can easily analyze the things, what is happening, like by varying certain parameters, how the things are changing. So those things can be easily studied using this steady state simulation. So only thing what you can say is it's more like your state function in the thermodynamics, which just goes from A to B, but it won't consider the path, right? So similar to that, it just gives you solution, but it won't show you what is happening in between. Like you give the feed, it will give you product, but what is happening in between, it cannot tell us. So that's where the next thing will come into picture is the dynamic simulator. So that's our DynSim interface, Aviva process simulation interface. So this, it will consider everything. Like the 2 things will be there, conservation of mass and energy. In addition to that, there will be few more like pressure flow dynamics also will come into picture. Ultimately, the fluid flows from high pressure region to low pressure region. And here, there will be different resistances in between. So it will consider that, and it will be calculating based on the flow passes or the flow nodes you have. It will calculate how much pressure drop is happening and how much flow it's supposed to go. And even it will include the holdups. As if I tell you, let's say if you have taking a shutdown and you want to replace certain heat exchanger or something like that, you cannot just simply open the heat exchanger when there is hydrocarbon in it. That is hazardous. So what they will do is they basically do the nitrogen purging, and then before doing that, they need to basically take off the liquid first because they need pressure to push down the liquid. So let's say you have some small system. I'll take one distillation column, overhead reflexer, reflex drum, and everything. And if you see, if you want to drain that, if you give proper volume and all, then we'll get to know how long really it takes in the plant. In case of emergency, something happens, if you want to prepare for the, in advance, if you want to prepare what is happening there and how long it takes, you can do the things from here itself, like drain, how long it will take and how much volume basically we are putting into the flare, or let's say if there is a backup vessel, how much volume we are taking it. So those things can be easily studied here. And this software can be also used for the engineering studies. So the earlier one was mostly can be used for HMB, and this software can be used for engineering studies, and the rating also can be done here. And the other important thing is the OTS, the operator training simulator. So this is where the training will come into picture, because what you're seeing there as a drum, right? So that has the actual dimensions, as if it has the real length and the diameter if you're given, and how much, let's say if you want to maintain certain level of material in that, how much it can handle and how long it will take to pump from that drum to the next thing. So those can be studied and get to know from here. And in most of the interviews, right, the major.
Finally, the screen is updated. So this is the Dynasim interface, and Anil was talking about this equipment here that actually takes the actual dimensions of the original equipment, right? So this has accumulation term into consideration for the simulation. I think there is a lag in updating the screen. The next one we have is process simulation and optimization together, which is Romeo.
Yeah, so this is a software which I was talking about. Most of the industries will be interested in, because that's where their profitability comes from. Use of it, they can improve further. So this can be operated in different modes. One is simple simulation mode. That's where you'll build the plant in the software, and the second one is the data reconciliation. So data reconciliation is nothing but let's say you have all the inputs. If there is any heat exchanger, you are giving one stream with certain flow rate and temperature, and there is another stream going on the other end, and they are there is a heat exchange between those two. So to find out, let's say you need certain outlet temperature to get the required duty. So that can be, these things can be tuned and so with this software, you will get to know what is the heat transfer coefficient required to get the heat exchange between those two mediums with a given flow rate and given inlet and outlet temperatures. So data reconciliation is the phase. That's where it happens. You'll give some known inputs, because this temperature, pressure, flow, these things can be measured from the field, and these will be taken as an input. And there can be some error in this because of the measuring instrument error. So those things can be rectified in the input here, and later on those can be used for even getting the final output, like unknown output like heat transfer coefficient and etc.
So basically, it also considers the redundancy of the transmitters. So in plant you will have transmitters, but there is no guarantee that you can rely on the transmitter. So for that reason, they have, let's say, 3 transmitters on the same line, right? If 1 or 2 of the transmitters doesn't work, it's there, the Romeo model plays a role where it reconciles. It doesn't look at, I mean, it can identify what is the error with the instrument and then reconcile that particular heat and metal balance and provide us the results. Okay. So again, it can also be used for heat and metal balance and then performance monitoring of assets.
Yeah, the next one is APS. So this is the one we have been working, like our R&D team is working recently, like past few years. So this one can be used starting from the design and then rating and all the way to dynamics testing. So this has all the features in it.
Yeah, it already is in market, and we are seeing a lot of traction, using this software. Essentially, you heard about Pro2 Dynasim, right? Imagine a platform where you can solve the design, rating, and dynamics all 3 together. So this is the platform, the software platform, where you will have a single model. It's just one simulation model, but you can do design, rating, and dynamics. So engineering studies also can be done in this particular software. Right now, predominantly it is into petrochemical complexes, the chemical industries, and all. It is also it can also be integrated with our other portfolio, Aviva portfolio that we have, the various softwares that we have. It can be integrated as well. Okay. Now specifically into operator training simulator, but before we go into it, any questions? No? Okay. Now let me connect back to my story that I've told. It was true story, right? That was a small pilot plant. Imagine I was there in a actual plant. I would have panicked multi times than what I was panicking in that particular pilot plant. So it is essential for a new operators to get training on their plant, and that's where our simulation or solution, which is operator training simulator, comes into handy. So these are our purposes. These are various purposes of having OTS. There are two types of operators, as you know, field operator and console operator. So this simulator can be used to train both field and control room operators, basically for efficient knowledge transfer and skill development. One of our major customers in United States, I think they at some point, all of their experts or experienced operators were getting retired. Obviously, they needed operator training simulators, so they approached us, and we have been providing this particular solution to them, and they are extremely happy and satisfied with whatever operator training simulators that we have installed in majority of their refineries and petrochemical complexes. So basically, it can be used to handle abnormal situations and unplanned shutdowns, and avoid unplanned shutdown, or avoid or improve, reduce the time for the planned shutdown. It can lower the risk of accidents. I mean, once the operator is trained, right, it can lower the risk of the accidents, increase operator awareness, basically improve his skills and readiness to operate the actual plant. It can also be used to familiarize the control systems. The process control is so important for the plants. He can get opportunity to actually familiarize with the control systems. It can also be used to validate process design and controls, validate the standard operating procedures, and so on. In fact, recently we came to know that one of the customers are actually using to interview their operators. Basically, they put them onto this OTS and ask them to, handle an abnormal situation. If they pass it, they are into their job. Okay. It seems, as per some recent report that was in 2014, operator training simulator for operators specifically is one of the most effective training methods. Like they do have on-the-job training, but again, it might happen what happened to me, right? Classroom training, they can be trained on other plants, but out of all these things, apparently operator training simulators is one of the effective training methods. Okay, this is our experience, the process simulation experience and capability. We have delivered, or we have our presence in 34% in various industries, right? So 34% of our operators, OTS, have been delivered to refining, then power and utilities, petrochemical complexes, and so on. So in refining, all of these major processes, CDU, VDU, the hydrotreaters, hydrocrackers, hydrogen production units, sulfur recovery units, utilities, fluid catalytic cracking. These are some of the complex units like FCC, DCU. DCU is delayed coker unit, flexi coker. These are very complex units to operate, and operators are getting benefited as they are trained on the OTS. Then we also have our presence in petrochemical complex, as I've been mentioning. This steam cracker or naphtha cracker is another complex one to operate in petrochemical field. And the MEG OTS, like we have delivered a couple of monoethylene glycol OTS to our customers. And yeah, so that's our presence. And so far since 2005, we have delivered 1,205 operator training simulators across 130 countries, I believe, using our workforce that we have in Aviva. And the pie chart you see here, this is where we can basically integrate our software or OTS with basically the Aviva dynamic simulation. It can be integrated with several DCS vendors, and this is our footprint with different DCS vendors. Okay. Now, how this is built, Radhika will take it forward.
Yeah. Ravi has explained the advantages and the importance of OTS. Now I will be talking about how we exactly build this OTS. That is how we do the simulation for a process plant. So the Aviva dynamic simulation uses first principle based thermodynamic process model. So once a project is confirmed, we will have an official kickoff meeting with the client where we have the confirmation of scopes and we do a connection of plan data.
Sorry, there is a lag in the screen. Probably let's wait for a minute. Any questions in the meanwhile? No? All are happy? We are also happy. Thank you so much. Yeah, it's updated.
Yeah. Here you can see this is the actual plan and this is the Bayesian interface which replicates or mimics the actual plan. So once before starting the simulation or before building the process plant in Ransom, we will be having the data gathered from the client. And this includes PFDs, PLDs, HMLD, and equipment data sheets. PFDs are nothing but process flow diagrams, which gives us the understanding of the process. And PLDs are the process and instrumentation diagrams, which gives the detailed information about the instrumentation and the control logics present in the actual plant. And the next one is HMD, which is very much important to do the simulation. This is the data which we use to validate the model which we have built.
So basically this real plan, right? The whatever let's take a CDU, starting from the battery limit, the tank, the storage tank, then the feed source drum, then the pre-flashers and distillation column, and then vacuum distillation column, and all the light-ins part of the crude distillation column, everything, including valves and instrumentation, will be simulated in our DynSim software. Okay, the Aviva dynamic simulation. It's a rigorous thermodynamic based software which can simulate any sort of complex problems that we have in the industry.
Yeah, once we build the model using the data which we collected from the client, we try to match it to the HNMD, which is nothing but the steady state condition of the plant. So once this is done, we do basic dynamic testing, and then this will be integrated with ESD logics. It is nothing but emergency shutdown logics, which is meant for the safety of the plant.
Yeah. So if there is a column and for some reason the liquid level starts coming down, right? You cannot operate the pump for a very important reason. That's it can potentially cavitate, right? So there the emergency shutdown logics play an important role. It trips that pump at that point when the level is low. So this is one of the example. So basically the process model that we build, which is the virtual plant, right, that will be integrated with ESD and that's done using TriStation software. This is also software that Invensys had. And we also we can actually implement the logics even in Aviva dynamic simulation as well. So that's how the actual plant or the virtual plant will be integrated with emergency shutdown.
Yeah, the model along with the logics, then it will be integrated with DCS. DCS is nothing but distributed control system. It is computerized control of a process plant. So here we have different DCS like Foxborough, Honeywell, ABB, Yokogawa, and so on. And again, Foxborough is a proprietary software.
So if you see here, your actual plant, the field bus modules or PLCs that are involved in the plant, all of those are simulated or emulated here in this case. And whatever HMI that they have in the plant, it will be exactly cloned and used, that will be integrated with whatever system or the simulation that we have developed. So this entire, the package is operator training simulator. Like we said, it will be used to mainly train the operators for the standard operating procedures for startup and shutdown activities. And this is how a typical OTS system looks like. Okay, so they exactly feel the plant in this solution. So they basically have all the dynamics involved in the plant. The field operator, he will have his field operations. The control systems and the control systems or stimulation will be done wherein I've explained how the DCS will be integrated. So the control room operators, the console operators will be trained on on their actual system itself, right? And finally, this is an addition to OTS, which we'll talk again. It's virtual or augmented reality. So basically, we have goggles, and once you have the goggles, you can feel as if you're walking in the plant. So this is the 3D part of the OTS. Okay. So let's move on to emerging technologies. Okay, which we have been working and started delivering to several customers. We talked about OTS, right? Now we have this immersive training system, which is essentially the extended or virtual reality that can be simply plugged into the OTS, and this entire system will be now 3D OTS. Okay, wherein both the field operator as well as console operator will be benefited out of the system. For Nestle, this is where I think we have delivered the XR system for them. That was in India. This is another technology which is which the solution is Aviva Unified Engineering. We also call it as digital twin because we have a central database wherein the PFDs, PNIDs, the 3D design which is developed by Aviva E3D, all of them can be integrated together with the process simulation softwares. Whatever you have heard, right? APS, Aviva process simulation, Pro2, Dynasim and all. So those can be integrated and it's a cloud-based solution. So this solution will be used in the entire plant life cycle, basically, starting from design to operate and optimize. This is another innovative technology or solution that we have. So it needs to be updated. Let's wait for them. Great. So Aviva Predictive Analytics and Aviva Process Simulation together. This is a software which involves machine learning algorithm. So artificial intelligence comes in the picture wherein historical data is utilized. So this software can be integrated with OSA Pi or any other historian databases that are there in the market. And a pattern recognition will be done by advanced machine learning algorithms that we have. Potentially, this pattern or the machine learning algorithm will help to predict the possible or potential asset failure. And asset in this case, it can be a compressor, it can be a gas turbine, it can be a steam turbine, or a distillation column and so on. So the Aviva process simulation, we can actually configure the performance calculations, like you can calculate the polytropic efficiency of a compressor, let's say, or the heat rate of a gas turbine. These will be the parameters that go into the Aviva predictive analytics software. The machine learning algorithm will be trained, and then it can be used to predict the potential failure of the asset. Okay, futuristic. So this is something that we are currently working with a major customer in the Middle East, and we are quite excited about it. Okay. Any questions again? It's not about distributed control system failure. I think as per study, it is 40% of the times it could be because of human errors. Okay. Yeah. Or for the accidents. Yeah, like I said, it can be like I think there was an accident in Baytown, one of the refineries, and it was because of they shift the chain, they changed the shifts, right, operators. So the transfer of what was being done in the previous shift should be properly transferred to the next operator. Apparently, that was not done properly, and the next operator was unable to gauge what is going on. So the distillation column actually flooded, right? And I think it was one of the petrochemical complex. It led to huge blast. So even this, like, even if you see this, right, this is kind of human error. The transfer should have happened properly, right? So whatever the OTs that you have heard so far, it will try to prevent such accidents provided the operators are trained properly. Of course, see, you need to have that skills of understanding what is, because this once the operator is trained in the system, the actual world is still very different, right? So yeah, so human error is mostly, like, I think it's 40% of the times it is because of human error. Okay, so and on the DCS, right, especially if we are if we have delivered a lot of grassroots OTS to grassroots refinery or greenfield plants, wherein the DCS will be it's a different software altogether, right? So that will be developed, but it will not have the feel of the plant dynamics, and that feel will be obtained with this process simulation, right? So let's say there is a major glitch in one of their logics. If you haven't tested it, or it's called as control checkout. If you don't test it, it might lead to, and if you don't test it and use it in the actual world, that can be, it can lead to an accident. So that control checkout can be tested in the OTS, correct it, and then fed back into the real system. Right, so that's how you can avoid potentially the errors in the DCS controls or even the emergency shutdown logics that we have talked about. Okay. See, those are little different. This particular solution that we have, right? This is where we can potentially predict the asset failure, right? Let's say there is a compressor and it is supposed to develop certain head, and there is certain temperature, discharge temperature that let's take a number. Let's say it was the discharge temperature was 300 degrees Fahrenheit, and slowly you see that 300, nothing changed. The operation is exactly the same. The 300 degrees started dropping down. What could be the reason for that? Why do you see a drop in the discharge temperature, or in this case, I should say, increase in the discharge temperature? Okay, as you will see that trend or the pattern that discharge temperature is increasing, and that is one of the main reason that the compressor efficiency is going down. Okay, so that's how you can identify, okay, what is going on. Maybe you need to clean the compressor. Like in the case of steam turbine, you have those blades, right? So if you notice that the efficiency is dropping using this particular solution, you can go and address or plan that maintenance activity, right? So that's how you can address such kind of complex situations. Any other questions? So after hearing all these things, do you think I should still go through this role of chemical engineers? I want one of you to actually know, explain us what is the role of chemical engineer, at least in process simulation. Anyone wants to give a try? Otherwise, I'll pick one of you. No one? There was a guy who said he is interested in automation. Can he at least? Yeah.
Yeah, it might be most of the time we are simulating here, but the main things we are trying to simulate is the actual plant. So the basic requirements, like as you told, energy and material balances will be carried out by a chemical engineer, because someone from IT or software department can simulate, but they won't have knowledge of material balance and energy balance. That's going to be the main role of the chemical engineer there.
Perfect, perfect. So basically, we have universal presence, right? You go to any industry, a chemical engineer is needed there. He can design a plant, he is involved in the operations. There are several industries out there. There are various roles in industries. One of such role is a process simulation engineer. Okay, there can be, you can be a shift in charge as you progress in, as you gain experience. If you go into a plant, you can get into research and development centers and whatnot, everything. So that's why I wanted to keep it simple. I will say universal presence for chemical engineers. Okay. Anything you want to add? Okay. I think that's all we have. Any more questions?
Sir, thank you, sir. Thank you for a nice lecture. And probably our students are most of the chemical engineering and other branch students also there. So what are how to upgrade their skills? As of now, the trend is changing from basic core chemical engineering to IoT, AI, and other process simulation based software. So how can they excel in their career if they might be upgrading their skills beyond the curriculum? So what are the skills required? Could you please give a brief?
First and foremost, be thorough with your chemical engineering fundamentals. Don't leave it. Okay. Next, there are a lot of data science courses available in market. Probably you can subscribe to them, learn data analytics, AI, machine learning. That's what the future is, right? I'll say that this is like, first is industrial revolution that we had, then information revolution. Now it is digital revolution, right? We need to digitalize across assets, and that's where in my first slide we had connecting people together, right? We need to connect chemical engineers, mechanical engineers, and all of them, right? So this is all possible if you enhance your skills, like data science is a new technology or upcoming. It's already there, so you can subscribe to such courses and learn machine learning, artificial intelligence. But before all these things, be thorough with your chemical engineering fundamentals.
Sir, any questions from the audience? Yeah. Sir, as we know, we have chemical engineering so many. I mean, not in count though, but companies recruit mostly CSCs, CSC engineerings, right? So what happens to chemical engineers? Like they will be recruited or no?
I'll tell you, demand and supply, right? At one point, it might, if you go to history, right? At least when I was coming out of IIT Bombay, I think we were 40 of us and 38 of us got placed. 2 went to pursue their PhDs. 38 got placed. Now maybe the numbers might have gone down, but I'm sure it will again pick up because you have industries everywhere. Chemical engineers are needed everywhere. Even in here, you have been hearing that it is a software, but who will run that software? Who will perform the process simulation? It has to be chemical engineer, right? So I see again an increase in the demand of chemical engineers for sure. And research, I'm sure Dr. Sridhar, I mean, he spoke about it, right? So research is another area. You have to be innovative. I think I was going through maybe one of your websites or Google, and I saw sky is the limit as the motto of BVRIT, if I'm not wrong. But you should not be limit. Right? Sky is the limit means it is limitless, but you can be limiting yourself. You need to enhance your skills. You have to be thorough with what is going on in the world and in the upcoming technologies, and you should not be the limit for yourself. Okay. Yeah, that's all I can say.
So one question. So as of now, whatever AI, ML, and data science applications are going on for a vast scale of research and all. Let's take an example of Google. Google's flagship research was on AlphaGo, which was a game. Go is the game from Korea and China region. And if we take applications of AI, ML, and data science on a larger scale, they are mostly centered towards the self-driving cars or something about gaming sector. They see it as a economically feasible and economically sustainable sector. But coming to the exact figures, the number of projects or number of research going on, I feel whatever going towards chemical is comparatively less. What do you think can be improved from entrepreneurial point of view or even the support from the government?
See, again, the solution that we have mentioned, about predictive analytics, right? That itself is an answer to your question. See, our industries definitely started using AI and ML. I think it may be wrong as well, or it may be fake, but I've read somewhere that Reliance wants to operate their entire plant with just one operator, right? So how is that possible? You need to automate it. You need to have artificial intelligence in order to control the plant, right? So this is an emerging technology. I'm sure, I think it will be, it is already part of our industry and it will continue. Any other questions? Cannot be, certainly it cannot be entertainment game, but OTS, right? I've heard a few operators saying that it's like a video game for us, right? So, yeah, I mean, it can be seen as a video game, but a serious video game, right? You need to understand. Yeah, certainly the 3D OTS or extended reality, right? If you have the goggles, you actually have a character walking. And if you give a command of opening or close a valve, so a character will walk to the valve, open it or close it depending on what command you give, right? So with that, not only the field operator is gaining that knowledge of how to open and close the valve, but it also gives you a perspective of how my plant is laid out, right? I mean, you can again go to YouTube or Google it. Distillation columns. We have all learned theoretically, probably Prabal is a textbook. We learn what is distillation column, Macabeathili and Ponton-Severett, huge algorithms and all. But we can't see the liquid and gas that is in equilibrium and gas or the vapor going up and the liquid trickling down and all. With 3D OTS, all of that is possible because you can actually it is animated. You can open the distillation column and see the liquid flow actually. Similarly, another major accidents that might happen is with heat exchanger leaks. Okay, so we can simulate that. In fact, we can see the liquid leaking out of tubes into the shell. So all of this is animation but with the chemical engineers in the background, right? So yeah, some of the operators actually say they are kind of video games to us.
I have a follow-up question to
Yeah, sure.
because when we are talking about all these processes, most of the education is in the form of text, and some
schematics and so on. So like what you said just now, it is it will be great to replace the textbook completely with something like a simulation based demo slash modeling kind of environment, right? Because these things are not easy to visualize, and then the steps in the processes, unless you see it, you don't really get it into your system, right?
Completely agree. Yes.
So is there anything in this that you are, I know the everyday problems and the process control, the design in a plant is different from the higher education side where the requirements may be a little different, but then are there things to help like collaterals for teaching and learning kind of things? Like you said just now, or one of you said heat and mass balance, you can just see it.
Yeah.
You don't see an equation, you see what is happening, right? That is much more powerful. So anything in that line, in that direction that you are involved in, or I mean, I know it's a challenge because going between industry
and industry, right? Yeah.
So
the first time I got introduced to process simulation or modeling and simulation was in my bachelor's. I heard it, but I got hands-on when I was in IIT Bombay. Right. So I think we had HISIS, we had fluid technologies where I had computational fluid dynamics, and so I got that hands-on. How did I get hands-on? Because the institutions actually acquired those licenses, they kept the softwares with them, and they actually have put process simulation or modeling and simulation as their curriculum, into their curriculum. So we actually had a subject that's modeling and simulation. So you can think of something of that sort. Right, and our recent software, or the most latest software, the Aviva process simulation, it is unique in the way that the equations that are involved in heat and metal balance, or any other complex equation, they're open. Any engineer can actually go and see which equations are used and how that particular function or parameter is being calculated. So yeah, that's what I can think of. Like you can acquire some licenses and train, or not train, but educate your students in that perspective.
So my question is the digital twins. In your talk, you mentioned about digital twins. So I mean, it comes with IoT implementation in the industry and with the simulation software that you have.
Yeah.
So, I mean, what percentage of industry today is using digital twins? One. Second, I mean, of course, we are in academia and we look for what is available to the students to kind of gain the knowledge. So, is there a rudimentary open source solution similar to Aviva process simulator? Any product that you suggest that students can hang out for venturing into Aviva product?
Yeah. So again, I think of MATLAB. Okay, that's another maybe software that I've used in my masters. MATLAB is one of them. Even C++ codes, right? You can create the flash algorithm. Any process simulation will primarily involve flash algorithm, wherein you get the feed, the saturated feed, and the vapor goes to the top, and that all the algorithm that is needed. That flash algorithm can actually be implemented in a simple C++ kind of languages. Yeah. And MATLAB, when they all must be learning differential equations, partial differential equations. Trust me, all of them are part of the dynamic simulation that we have, right, in the background. So you can teach them how to solve differential equations, partial differential equations using MATLAB. Even C++, we had. I still remember I was struggling in that particular code, but I had to solve differential, especially partial differential equations. I've used C at that time, C language. So yeah. Yeah. Let's see, thousands of lines, or if they're intelligent enough, smart enough, the 1,000 lines can be reduced to 500, right? Yeah. Yeah. Yeah, visual field you won't have, but I can tell you that the fundamentals will be very thorough because you are the one who will be writing those equations, right? Yeah. Okay, so that's all we had for now, for today at least. So I hope the session had enlightened some of you or maybe most of you, and it was helpful. Okay, and probably and we believe we have met the objective of this session. Okay, thank you. Thanks a lot.
Thank you. Thank you for sharing how Aviva was formed and awarding, giving us awareness about how OTS, Operator Training Simulator works, and how Radhika ma'am explained how it was started and all. And it was a very awareness program, and it's kind of cool that we got to know that you can just put on a 3D glass and know what is actually happening. So technology keeps us wondering all the time. Thank you for that. Thank you, sir. Thank you, thank you.
Thank you, sir, for the profound knowledge that you shared with us. Now, I request Dr. G.B. Radhika ma'am to honor our Ravi Shankar Chaudhary Garu with the memento. Students, సడన్గా చెప్తారు కదా. Sridhar. I request Kiran Kumar Garu to honor Radhika Garu with a memento. I mean, that. Yes. Finally, I request Dr. Sridhar Garu to honor Dr. Anil with a memento. Thank you all.
Thank you. With this, we end this inaugural session, and we'll meet after lunch break. We'll continue with this session, the participants doing the presentations. Thank you.
Thank you all. It will be of 45 minutes and will begin after 45 minutes. Thank you all.